Hi everyone, welcome to another live coding stream. In this episode of live coding, we'll be doing something really cool. We'll be showing a new feature in PerceptiLabs where we deploy models as Gradio apps. So I'll be showcasing this with 3 different models. 2 of them we already done before. So the first one's going to be a COVID-19 dataset where we classify different MRI scans, not MRI scan, X-ray scans, sorry. The second one's going to be the Bob Ross paintings, and the third one's going to be a very silly data set based on just some random digits to show how that looks like as well. So let's get into PerceptiLabs and get it started. All right, so here we are. So as a reminder for anyone who did not see the COVID-19 or the Bob Ross datasets yet, I'll be going through them when we get to them. The first one we'll be starting with is the COVID-19 dataset, which looks like this. You can find it on Kaggle, and you have a bunch of X-ray scans here where you can see different lungs, and you can see if they have COVID, normal, or viral pneumonia. I hope I pronounced that correctly. So we're going to take these images and essentially build a classifier of them. And then we're going to use that classifier to run a Gradio app. And for those who are not familiar what Gradio is, it's a open source framework, which the best way to show it is going into their hubs. You can essentially create a machine learning app by using Gradio, which spins up a little front end like this, where you can add in different images, and you can essentially run them. Well, not just images, you can add in data, and you can then run your model on the data, and you get to see the input and the output straight in the app. It's very handy for demoing machine learning models and or showing them off to other people. So let's get started with the COVID-19. First thing we're going to do is just load the model. So I'm loading the CSV file. Oh, hold on, let me try that again. All right, let me refresh the front end real quick. Heads up as well, this is the latest development branch, and there might be some things unexpected here and there, but it should in general run pretty smoothly. There we go. All right, so I'll just create a normal image classification model. Images goes in, labels becomes targets, they're categories. You can create a model, and we'll get this. And we're not going to do anything fancy with this first one. Actually, we're not going to do anything fancy with any of the models unless we get some good time over. So all I'm going to do here is leave the recommendation as it is. Just hit run, lower the epochs a bit, and we'll set loss to cross entropy at least so we get some decent results from it. And then we'll just let it run. Yeah, one more thing here in the statistics view as well, which I can show. We have a new tab called Performance, which will show you the precision, the recall, and the F1 score. And what's cool in here is that you can choose which classes you want to see them for. And you can also choose if you want to see them for validation or training. For training, they generally will always go up, at least they should. It's very similar to accuracy in that way. But for validation, it can be very interesting to look at how the precision and recall is behaving, the F1 score as well. I'm not going to dig into exactly how precision and recall works here, but a very brief overview of it is they'll let you know how many of the correct samples you found out of the total, and how many of them were correctly classified. Very roughly. It's to explain precision recall is usually best done with images, and there are some good resources out there. But yeah, it's now in the tool, so you can see how they vary as you're training. But after the training's done, we can always evaluate the model, but we're gonna go straight into deploy instead. I believe I may have showed this, the new deploy view last time, but the functionality-wise is very similar to the existing one. It just looks a lot nicer, and it includes fast API as well as Gradio. TensorFlow is the same as before. You just get a model which you can put into deployment using your own script. Nothing fancy or strange there. You can of course compress it and quantize it as well, which is awesome. But the fast API takes this exported TensorFlow model and it builds a little script around it. So you just run that script and you will have a REST API built on fast API up and running, which you can send requests to. And that's essentially a serving environment, which you can use for production. So it's a really easy way to get a production environment up and running straight away. The last one is Gradio, which is the one we're going to look at today. And, well, I already showed the website, so let's just click this button. And what's going to happen is it will spin up Gradio app for this model and open it in a new browser. And there we go. So here's our model live. Now I just press on one of these and let me go into the correct folder. And I didn't look at what the accuracy was of the model. The precision recall looked decent, so the model should probably be okay. So we can try sending in one of these normal, submitting it, and we get a class normal. Or we can send in a viral pneumonia, and we get that predicted correctly. So that's how you can have your model up and running very, very quickly to demonstrate it or to try it out on new images or data or however you want. So that's the first model. The second two is just going to use the same concept, but for those, we're going to try some different models. So we'll be starting with the Bob Ross segmentations. And this was a very recent one I did. What it does is it takes Bob Ross images and it segments them. It picks out the happy little trees, it picks out the rivers, the sky, I was about to say the air, the clouds and everything like that. So you can, you segment what's what inside the image. So let's create a model around that. I can find the dataset. There we go. And we'll put this as a mask. And we'll make sure that the images go in are 224 by 224. At some point, not too far away, we're going to make this a standard recommendation instead, so you don't have to go in and do this every time. All right, so there's our recommended model. Again, we're not going to do anything fancy here. We're just going to run it with some decent settings. And then spin this one up as a Gradio service and see how it goes. while it's training, we can always take a look at the prediction versus the target. All right, not the best IOU in the world. They're not 13. But from experience from last time we did this dataset, you can get quite a lot higher by just letting it train for longer. Let's go in and deploy this one. If we have time over, we can... I'm sitting on a better machine than last time I did Bob Ross, so I might either redo it or if we have time over here, can try it again. I also realize you guys can't see the file chooser or the file picker, but obviously whenever I press this drop images in here, I get a little file picker up or file explorer, which I can use to pick exactly which image I want to send in. So I'm just going to pick a ROS image here, and there we go. Again, not the best IOU, not the best segmentation, but we can see how the mask would look like. We can try a few different ones, see if there's any which looks... well, that one is not a good example. See if we can find any other one. You can see that it started segmenting a few parts. But yeah, if... it looks like we're going to have some time, so we can make it a goal to see how well we can get the Bob Ross model running in Gradio. But before we do that, let's jump into the last dataset real quick to see. We're now seeing how it looks like with image classification, how it looks like with image segmentation, and the last one I want to showcase is a dataset which just is a bunch of digits. It's actually just 3 columns of digits, but to show how it would look like if you don't have any images at all. So this is how it looks like. It's very much not a real life use case. It's just the same number, I think 50 times over in 3 different columns. But it does showcase pretty well how it would look like in Gradio. So let's take 2 of these as inputs. We'll take 1 of those as targets. Then we can create the model. And as per usual, we'll multi-input. Things crash a little bit. We're about to get that fixed. But if you just delete all the layers, it's easy enough to drag in a new merge component. Can concatenate them. Like so. And then just drag in a dense layer with which are none here and a single output. Right, nothing fancy, but it'll do. We can go 10 and batch size of 8 again. Here we want quadratic. We're essentially doing regression. If anyone's curious what the different losses are for, cross entropy is for anything classification, multi-classification. Quadratic is in general for regression, and dice score is in general for either object detection or segmentation, binary segmentation. You'll have to be careful with that. If you do multi-class segmentation with dice, it's not going to work as well as you might hope. In that case, cross entropy is a bit better. So let's just run this model. And I don't think I've showcased a regression model, at least in a long time. What's interesting to look at, well, all these 3 metrics are interesting to look at. The loss is essentially the, let's see if I get this right. I believe you want to take the square root of the loss to get the actual error. And the actual error is how far apart the predicted value is from the label. In this case, we have, so we were down at 5 zeros before the first digit. So I think we're good with this model. It's a very, very simple one since we're just mapping 1 and 1 to 1 and 2 and 2 to 2. But yeah, we're getting a little bit more support soon for regression as well. But let's jump into deploy. We'll take this model and we'll do a Gradio for that one as well. And then it looks like this instead. So here, instead of just sending in an image, you can write what you want in each of your columns. So 5 and 5 should be 5, fairly close. We had a little bit of error, but it's close enough. I believe there was 100 columns, so let's see if it generalizes up to 500, which it does. It's not getting any worse. It's not a very difficult problem. It's a straight line. We can also try things like happens if we put in 10 and 1, and it gives us somewhere roughly in between. So in this way, you can sit and play around with the model to see different extreme cases or how it acts on different type of data, which maybe you didn't train on, or maybe you didn't have in the in your test data set when you ran on that. So it's a very handy way to do that, and of course also to host this and show other people how your model was going, which there's getting a bigger and bigger community around that with Gradio. They're pushing a lot on their hub, where you can upload different models, different Gradio apps, and showcase to other people. All right, but that's how Gradio works, and all of this will be out in less than 2 weeks at this point. So look forward to that. I know I am, at least. But for the remaining of the time, we can try to train a Bob Ross model so it looks a little bit better, so it's a little bit more fun to try out in Gradio. If anyone has any questions as well, just feel free to write in the chat, and I'll be happy to try to answer them. But in the meantime, I'm going to try and see how well I can do this. And the first thing I'm going to do is activate batch normalization, because that has been working really well for me with units in the past. So let's see how that works. And the training went pretty quick, so let's bump this up. Let's bump up the batch size. So let's not go overboard. Let's try 16 to start with, and see how that works. Right. Okay, I'm gonna have to restart the kernel real quick. As I said, dev environment, that's another little thing that's getting fixed soon. Currently we have the fun little bug that if you start a model that's already been ran, it fetches the old statistics, which is not ideal. Let's start this one up again. And we run it. You don't need to run from that. All right, I thought restarting that would do it. Okay, then give me 1 more second. Sorry about that. That should work better. There we go. No longer instantly done. I might have to lower the batch size though, yeah. Let's drop that down to 8, see if that works better. It's going to take a little bit longer to train them, but that should be fine. Let's see if this works. Otherwise, we'll leave it on the up nodes that Gradio works. There we go. Right, let's see if we can get an IOU over 0.4, 0.5. That would be pretty cool. Then we could get some decent segmentations. I mean, some images are really good already. It's getting up there. The validation is fluctuating a fair bit though. But even so, it'll be fun to look at the training samples. Alright, there we go. I believe this was model 12. That's why you should name your models. And it's not extremely much better, but it's slightly better. So let's see if we can get some nicer out of it. Not a good example. Let's try another one. Also not a good example. Maybe the longer you train this model, the worse it gets. That's true to some degree. Yeah, batch normalization might not be the best for this one. But at least you can find it out and see exactly how bad it gets. If we skip Gradio, we can go back here and just see if we got any good outputs, predictions. Here we go. So this would be the best ones. And yeah, it looks like either it was a mistake to put on batch normalization, or we should have left the training for just a bit longer. But I think that's it for today. I hope you guys enjoyed it, seeing a few different data sets and how they work in Gradio. And I'm very excited for you guys to get this in your hand, to try it out and play around with it. But have a fantastic day, and thanks a lot everyone for watching. Take care.